Hi, folks. Welcome to our Kadena Eco Project Spotlight. We have an awesome AMA for you all today that we're going to showcase some of the exciting projects building on Kadena, some of the people behind them, and delve into a really exciting area of technology and crypto right now, zero-knowledge proofs and ZK snarks. My name is Tyler Benster, and I'm the tech adoption lead here at Kadena Eco, which is an innovation network that's powering much of the ecosystem growth and supporting the builders and the entrepreneurs and the projects that are innovating on Kadena, an innovative layer one blockchain that solves the blockchain trilemma. I got started with Kadena back in 2017 as an investor, and most recently in this past year, I've come on board to help contribute some of my efforts to the project, as I'm just so excited by where the ecosystem is at today and how much growth there's been. We're tracking literally hundreds of projects at this point that are building on Kadena, applying for grants, and excited to power the next growth in blockchain and Web3. So this week, we couldn't be more excited to spotlight the founder of Electron Labs, Garvit Goel. Electron Labs is a ZK rollup company that's bringing on-chain privacy to distributed apps and users, and it's built on Kadena. So thanks so much for joining me today. I think we're gonna have a lot of fun talking about this project. I'm gonna go ahead without further ado and welcome Garvit up to the stream. Hello.
Yeah, hi guys. Thanks, Tyler, for having me here.
Yeah, we're really stoked to have you here. Wouldn't you mind by just getting things rolling by giving us a quick introduction to yourself and your background?
Yeah, absolutely. So hi, I'm Garvit. I'm the CEO, founder and CEO at Electron Labs. I'm a chemical engineer by training, started a company called Fraction OX before this, which was into tokenization of real world assets back in the previous bull market. Then a year back, we started working on ZK technology and started Electron Labs as a result, and working on bringing really cool ZK technology to the masses. Yeah.
Right on. And I'm curious how you got your initial spark of interest or curiosity in crypto and ZK, if you wouldn't mind sharing that backstory.
Yeah, absolutely. I think this was back in college. I think in second year, I was reading this magazine called The Economist, and they mentioned an article about this. At that time, I didn't really get it. They were even talking about ICOs, etc. at that time. So I left it. Then I think in 2017, towards the end of my graduation, I was basically looking for which sectors to focus on to basically start a company, and then started to get into blockchain at that point again. And the idea of self-sovereign money was really exciting, and it kind of just pulled me in, and been into the space since then.
Right on. And how about zero knowledge?
Yeah, I mean, so we actually got into zero knowledge to solve a problem in crypto itself that we were working on. So initially we were working on building bridges between various blockchains. This is around I think last year, maybe 7-8 months back. And while trying to work on bridging technology, we realized there were a lot of limitations. And that's when we actually started to look into ZK tech to solve some of those problems. And like initially we thought that ZK was quite ready and we would just integrate that within our tech and the problem would be solved. But we very quickly realized that ZK technology itself was quite not ready for building the kind of products we were planning to build. But at the same time, we also came across the potential of ZK technology. And that's when we actually decided that we are going to be not a bridge company, but a ZK company. And that's when we started to work on this.
Right on. So we're going to dive a lot more into the technology, into Electron Labs, some of the framing, some of the possibilities that are opened up by ZK. But one final question just to help frame things is, how did you get introduced to Kadena?
Yeah, so actually William was hiding in our Discord for quite some time and we didn't know. Like an L1 founder hiding in the Discord, like we were, I think, like, I don't know, 50 people in our Discord at that time. And then we ended up chatting with each other over DMs, and one thing led to another, had a call with him. And he was really looking forward to building ZK stuff on top of Kadena. And that's exactly the kind of technology we were building. So yeah, found the perfect fit there.
That's awesome. Those that have been around in Kadena since the early days know that Will has a habit of hanging out on Telegram or Discord or wherever, and suddenly chiming in with these incredibly thoughtful posts and dissections about technical questions. And I know ZK is something that's near and dear to Kadena Core's heart in terms of some of the possibilities that's going to open up. So just one last comment for the broad audience that's joining us today. We will be taking questions, so please feel free to comment or tweet, or if you're whatever platform you're on, LinkedIn, YouTube, Twitter, feel free to drop a question in comments, or and we will try to get to some of them at the end. But in the meantime, I want to really dive in a little bit on ZK. We know that zero knowledge has become quite a big of a buzz phrase these days, but I think that knowledge about what that actually means is still distributed and not always consistent among those within the space. I'd love to hear in your words, what exactly is ZK? What is zero knowledge?
Sure. So basically, ZK technology is a new kind of a cryptographic construct. Like we have digital signatures, we have hashing schemes. ZK is another kind of a cryptographic construct that gives you these magical mathematical properties where, let's say, the amount of computation that you have performed can be significantly compressed. And the best property that I personally like is that you can perform computations without actually revealing the numbers that you're performing those computations on, right? So these are some mathematical properties that can then be exploited to build really interesting use cases.
Fascinating. So when we talk about ZK, we often hear people use these days ZK snarks. Could you explain a little bit what a ZK snark is and how that relates to ZK?
Sure. So ZK technology is more of an umbrella name for all the zero knowledge technologies out there. And snark is basically one kind of ZK technology. There are several kinds of ZK technologies in the market. I should not call it technologies, but more of schemes. So snark is one of them, which is the most popular one. Then you have things like Plonk, which is again a snark variant. Then you have Starks, which are supposed to be very proof-friendly. Then we have bulletproofs, which is a very new and upcoming piece of scheme. So yeah, snark is just one basically type of ZK technology out there.
Got it. And what does snark stand for? And I guess, could you give some coloration for why snark has become particularly possible or particularly popular rather?
Sure. So I think snark stands for, if I'm recalling correctly, synced non-interactive arguments of knowledge, right? So what that, so the reason, okay, let me get to the second part first, which is the reason these have become so popular is because first of all, snarks are quite easy to use. Like for some of the more technical savvy guys, you can call snarks as the JavaScript of the ZK world. Like it's the first thing you learn when you learn about ZK technology. It's the most well documented, and generally it's quite easy. Second reason it is so popular is because the Ethereum chain actually accepted pre-compiles for this particular technology onto their main chain, which basically means that anyone building on Ethereum has to use this. They don't really have a choice. So that's also one of the reasons it became so popular. I think there's another reason it became popular is because the verification cost of a snark is quite cheap, which makes it extremely friendly towards blockchains because blockchains have extremely limited resources in terms of what you can actually do on chain. So a very efficient verification actually makes it quite attractive for using along with blockchains.
So I've sort of this mental abstraction. I'd love to learn if it's accurate or should be revised. Where I've kind of been thinking about ZK snarks in a way as almost this abstraction of hashing, where you, in a classic hash function, you just have a bunch of text and then you turn it into this short string, and it's very easy to verify that hash is correct, but it'd be very hard if you just have the hash to figure out the original content. And a ZK snark, as I sort of conceive it, has a similar property where you can verify if a computation was done, but going back to kind of what the inputs of what the computation was can be a little bit more challenging. Is that like a reasonable mental model, or how would you adjust or revise that?
Yeah, it's quite similar, but let me build on that a bit. If you talk about existing like pre-ZK encryption schemes or cryptographic schemes, all of them involve hiding numbers, right? Once you've hidden the number, then of course it's encrypted, you can share it around and somebody else can decrypt it. But what ZK technology allows you to do, it allows you to perform computations on encrypted numbers, right? So for example, I could encrypt a number, let's say 273, and then I could share it with someone and only they would be able to decrypt and see that the number is actually 273. But with ZK technology, I can actually perform computations on, let's say 273, 500, I have, let's say, a bunch of numbers. I can add them together, perform some other computations. And then the verifier doesn't actually have to know these input numbers. They can actually still verify that certain numbers were actually added together and those numbers satisfy certain other mathematical properties. And it could be any mathematical properties, right? For example, you might want to verify a signature. which is entirely a mathematical process. So you can actually verify whether a particular digital signature is valid without revealing the signature itself.
Perfect, thank you. One of the powers of the abstract is, of course, that you can apply a principle, a concept, a map to a number of different possibilities, a number of different applications. One of the challenges when we encounter a new abstract concept that doesn't map onto, for example, existing businesses or existing experiences that many of us have in the day-to-day world is that sometimes it limits the imagination. On the one side, anything is possible with ZK Snarks. The other side, what the hell are they? What can you do with them? I was wondering if you could help, for those of us in the audience that are newer to ZK Snarks, what would be some applications today for the technology? And then second, what might be some applications in the future?
Sure, absolutely. So I think my personal favorite application for today is privacy transactions on top of blockchains. So if you look at any blockchain today, everything about a user, every transaction, every data point is completely public. And that's how it works. That's the fundamental design behind the blockchain. But the cool thing with ZK, what you can do is you can perform transactions on top of these blockchains without actually revealing the contents of those transactions. So Tyler could send money to Garvit without actually revealing that Tyler and Garvit are the counterparties in this transaction, or even revealing the amount of transaction, the amount of money that Tyler sent me. And this actually, allows you to build a host of new kind of applications, which are privacy preserving for the user, which I think, people haven't even started. I personally believe people haven't even started to think about those applications today, because the concept of privacy does not exist in the blockchain space right now. And interestingly, that was the problem for which blockchains were designed in the first place, that to give more privacy to the user. But it's actually just the opposite that what's happening right now. I think that's the use cases I see today. I think going forward, it's hard to say at this point what will happen. But the way we like to see, like at Electron Labs, we believe that most of the use cases of the future, they will get rolled up inside some ZK rollup, just because it's either more scalable or it's more private. I think, yeah. And I think just because of this technology, I think we'll see a host of new applications emerge, which we haven't even seen so far.
Right on. I think that's something that's pretty exciting, is that as blockchain itself becomes more prevalent and we start thinking about the advantages of distributing information, there becomes this natural question of, well, actually, do we want everything to be public? Sure, an account name could be pseudo-anonymous, but there's been plenty of demonstrations of how you can look at blockchain ledgers and records and ultimately identify or come close to identifying who might be attributable to a particular account or certain transaction records. And the idea, for example, of if all my credit card records were public knowledge, maybe there'd be one or two in there that I'd be embarrassed about, or maybe there'd be some aspects of everyday life that people don't want to share. And so I think that this idea of saying, hey, decentralization is incredibly powerful. Decentralization allows for all these benefits in terms of trustlessness, in terms of censorship resistance, in terms of allowing applications to scale in a global way and cross borders, et cetera, but it also is severely limiting in a lot of aspects where sometimes you don't always want that to be fully public. We want to be able to have sort of this veil. And it seems to me that ZK Snark is going to serve this really interesting intersection point that sort of allows for this core advantage of blockchain to actually be realized, given sort of the practical social implications sometimes of this decentralization.
Yes, absolutely. I totally agree with that. In fact, this actually happened with Mark Cuban. Like people figured out his address on chain, and I think there was quite a lot of all his money on chain was eventually getting tracked, and people could actually see all the money that he was losing in NFTs, and people would actually send him DMs as a result of that. I think it's quite embarrassing, and I think if Mark Cuban wanted to hide his wealth, I think he would have to first of all sell all of his crypto, get back into a bank account, then buy it back, and then make sure that he continues to hide that address. I mean, that's a huge problem. And I think if you extend this concept, like if you talk about social networks, right? Eventually, you want to see social networks on top of blockchains. I think there's hardly I don't think so. You would be okay with a messaging app where all your messages to your friends are completely public to everyone. I think those use cases cannot be built today because of the privacy problem. And I think hopefully ZK will solve that.
Right on. So something I want to get into now is a little bit more on the technical and technology side. So a common theme in Web3 has been in trying to understand when it makes sense for something to occur on-chain and when it makes sense for something to occur off-chain. And sort of at what point do you settle to the chain? I think there's sort of different philosophies and emphasis here depending on what blockchain you're talking about. But I would say that basically all of us agree, for example, that you probably don't want to store the HTML for a web page on-chain and retrieve it. It'd just be way too much of a mess to pick it up. And then plus everyone that is mining or everyone that is serving as part of the ledger would have to store that information. You might use a more specialized IPFS or other type of backend system for such a thing. On the flip side, we've settled that, for example, if you want to do transactions, you can do layer twos to group a bunch of transactions together, but there's some risks associated with that, and there's been some pretty serious hacks that have been associated with some of these different bridging and type of other operations. I guess what I wanted to get at is when we talk about ZK, we often hear about ZK rollups. So I was wondering if you could tell me a little bit about what does a rollup mean in context of ZK, and how does that, why is that technical approach being described and used by many for implementing ZK in crypto?
Yeah, sure. I think that's a great question. So let me try to simplify it. So whenever you come up with a new scheme or a cryptographic construct in this case, the challenge before you is that the scheme itself or the technology itself cannot be just applied directly, right? You have to build some scaffolding around it. You have to build a product around it so that the technology itself remains the engine, but the product is what is actually delivering value to the user, right? So I think a very good example, of course, that is the Uber app, right? You're not actually worried about all the backend servers running behind Uber, but you just want a taxi fast, right? So the product is the taxi, but obviously the technology is right. So I think that's where the concept of a rollup comes in. That once you try to combine together the concept of ZK with the blockchain, you have to add some scaffolding around it so that it actually makes sense to interact with the blockchain using ZK technology. And that scaffolding and all that structure around is what we essentially call as a rollup. Sometimes basically people sometimes think that the rollup is kind of a very limited scope. Maybe the concept can extend a bit beyond that. And I think to answer that question, I think rollup as a concept is actually quite generalized in terms of applications you can build. I think everything you can build on a blockchain can be built on top of a rollup. I think the naming is a bit bad. I think it should be called something more like I don't know. I'm not sure what the naming should be, but rollup kind of is a bit misleading over here. Having said that, there are a large number of applications for ZK technology beyond the rollup concept. I think we are working on some of them. I think, for example, our partnership with Kadena is also on a similar concept, where we are providing our infrastructure where other dApps can just consume our API endpoints to build dApps on top of Kadena. Interestingly, most of those apps are likely to be rollups themselves. But yeah, I mean, I think, if you talk about other concepts, maybe in bridging, for example, if you talk about light kind compression, that's also some of the projects we are working on. Hopefully, we'll work on with Kadena also as a part of this partnership, where the technology, the product that you're providing is pure computational compression. It has nothing to do with the concept of rollup. But having said that, yes, I think most of the applications today are around.
Right on. So what do you see as some of the main risks or downsides of a rollup implementation for ZK?
Yeah, so I think that's a slightly broader question. So if you talk about downsides, I think the biggest issue with ZK technology is it's so new. I wouldn't call it new. It's so hard to work on. Like there's so few people working on this that when we try and hire ZK engineers, we just gave up on even trying to find one. We essentially developed our own, we train people ourselves internally at the company. And I think this is the biggest challenge when building a ZK based application, that how are you going to actually find people to build this? And how are you yourself as a founder or as a CTO, are you going to find information that allows you to build this stuff? In fact, we struggled with this for around 6 months at Electron, that we just couldn't find information around this. In the end, we became really good with it ourselves. And we eventually made this our mission at Electron Labs, that we are going to simplify ZK technology so that the average developer can pick it up.
Right on. So I think that question of how we actually take some interesting abstract mathematical ideas and translate it and make it easy for people to use is really a core one, right? So for example, crypto and Bitcoin and blockchain, in some sense, productized these cryptographic ideas. Someone in 1995 could have used by hand, this document ledger where you built upon whoever's last transaction had happened and construct a proof and submit it. No, one could in theory do this literally by head. But of course, that would have never worked as a payment system. And so I think some of the beauty of Bitcoin is recognizing that it wasn't so much that Bitcoin introduced any new cryptographic ideas, or even for that matter, cryptographic implementations, but it really solved this user experience problem of how do you manage to store these sort of hashes, how do you store these Merkle chains in a manner that everyone can view them and everyone can use them, and just how do you get consensus around getting these transactions into a ledger that can then be actually tabulated with these UTXOs. So when I think about ZK snarks, it's interesting because there's a similar hurdle where the cryptographic community has been super excited about ZK for a while now, but from the developer perspective, it's still a lot of a much newer concept because it really isn't easy to just go somewhere and take a tutorial and be up and running using ZK snarks overnight. The hello world of ZK snarks is still, I think, fairly complicated. So I guess when we think about developer tooling, what do you think are some of the key aspects? What needs to be there for the developers to be able to really start building with ZK? And what do you think would an ideal sort of API or user experience look like?
Absolutely. I think you've asked the most important question over here. So when we try to essentially come up with a abstraction or a mental model for the developer, I think this is something, this was a major discussion we had at Electron a while back. And the biggest challenge for this is that, let's say you talk about the privacy applications of ZK technology. The problem is that the notion of privacy, this notion has not existed before. Like, you obviously maintain privacy in a very different way in the Web 2 world, but at a programming language level, the notion of privacy just doesn't exist. There is no existing programming language in the world. Even if you talk about the most primitive ones or the most popular ones, the notion of privacy is simply not built into these languages because this technology has not existed before. So I think this is the biggest hurdle to adoption of the privacy use cases. Is like, this is a problem we are trying to crack. That how do you not have? You should not be as a developer. You should not be asked to learn a new programming language that allows you to build these privacy-preserving applications, right? Can we somehow introduce syntax inside an existing programming language, such as Pact or let's say Rust? Can we introduce additional syntax such that the smart contract layer itself can start supporting the concept of privacy? The problem is, the bad news is that we haven't figured out a way around it, and so far it seems that we will have to come up with a new programming language to solve this problem. So that's for the privacy use cases. I think when it comes to the scalability use cases, I think things are a bit easier because you can adopt existing frameworks or existing VMs and make them ZK compatible. I think some of the work that has been happening around this in the ZK EVM space is quite interesting. But yeah, I mean, I think the really large use cases are going to come from the privacy aspect, and it seems that at the moment that one has to launch a new programming language, which we're trying to figure out that we don't have to do that.
Yeah, that's absolutely fascinating, because I think it really just highlights this theme that we have this incredibly powerful new toolkit in the cryptographic sense, but for mainstream developers and for projects today, it's fairly inaccessible. And I think that's part of what's so exciting about this new collaboration with Electron Labs, is to help bring that power of ZK Snark in a manner that projects can more readily build on. So I guess if you were to sort of project forward and imagine that the project goes really, really well and we achieve sort of our wildest dreams, what might it look like for someone that is a builder on Kadena to then leverage some Electron Labs technology and to leverage ZK snarks? What might that experience look like if all of our dreams come true?
Absolutely. So I think ideally we would like to see a pact-based SDK that developers can directly access as a smart contract library that they can just import and start using. Ideally, a developer shouldn't even be aware, or at least shouldn't be required to be aware that they're using ZK technology. They should somehow just know that there's this magical property that this particular library is giving you, and that you can use that. So we would like to see this happen in Rust and Pact. But I think in order to achieve that, it's not an easy goal and probably will take quite a while to get there. But I think this partnership is definitely headed in that direction.
Right on. Yeah, I think it's all about saying what are the most obvious next steps that help get us closer to that, and then working tirelessly towards that vision, I think is so exciting. Of course, with Pact, we have some flexibility because the language has been developed by the core team, because the language has certain interesting properties like Turing incompleteness that make it easier to formally verify, that make it easier to sort of scope out what's possible in the language. I think that Rust, of course, has its own unique advantages and constraints. Rust, of course, has beautiful low-level memory management, the borrowing system, some really cool language compiler constructs. And so I think it's fantastic. I think that you folks are approaching it from multiple angles, because I think that will sort of help elucidate what some key challenges or hurdles or opportunities are. How much of the language can you actually incorporate into sort of a ZK snark land? Do you have to effectively build a domain-specific language inside of the programming language itself, or can you sort of try and encompass more and more of the constructs? I think it's going to be really, really fascinating to see how this API ultimately looks across Pact and across Rust. So I want to make sure that we have a little bit of time. We have a few questions that we're going to jump to from the audience. But first of all, I wanted to ask a last question as it relates to the user experience of someone that would then be using one of these potential applications built on top of this technology. Would there be additional fees when using ZK or using ZK rollups, or how does that sort of implementation layer of the ZK validation actually get implemented in terms of sort of an economic or tokenomics or other infrastructure?
Yeah, absolutely. So I think on the user experience front, we have some good news. We can actually, at least we have figured out to offer the exact same user experience as right now, right? People crypto users are already getting educated about using crypto wallets in the browser and interacting with the blockchain. We are able to offer a very, very similar user experience. Like, you don't have to kind of learn any new kind of like a lot of people have to be educated how to use browser-based wallets. But I think that re-education does not have to happen. Most dApps will be able to integrate this within the existing UI infrastructure, and the user doesn't even have to know that this upgrade has taken place, and they can simply start getting the benefits of that. On the gas fees front, again, we have some very good news that ZK technology actually reduces your gas fees, because you can, you're performing a large amount of computations off-chain on these cloud servers and just putting the proofs on-chain, which actually reduces your transaction fees quite a bit once the network effects kick in. So I think, on those fronts, I think it's quite exciting. And that's also one of the reasons why we believe that ZK is definitely the future. Yeah.
Right on. Some quick audience reactions here. We have from Qualaman that the privacy sounds very useful, and also from Web3 that the privacy hurdle with Pact will be interesting to track. Yeah, I think this will be super, super interesting to see what possibilities that this opens up. I did want to jump to a question from Liam Hill that was interesting, and I'll provide some context for this. How does this compare to Kuro? For those that aren't familiar, Kuro is a layer 2 solution for Kadena that allows for higher degrees of scalability. So just to sort of broaden this question such that it's applicable to a variety of circumstance, how does this ZK rollup concept that we're talking about specifically compare to what most think about as layer 2 rollups today, which are more about transaction rollups.
Yeah, absolutely. So I think one of the cool things, one of the hard things essentially when it comes to privacy-based technology is that how do you really make these rollups programmable? If you look at if you look at most rollups today, or let's say privacy applications, if you rather look at the privacy applications that exist today, such as Monero, Zcash, they're quite limited. For example, they only support transactions. But what we're essentially trying to take this forward to, can we actually make this programmable in general? So yeah, I think that's one of the hard problems that we are working on.
Yeah, absolutely. That makes a lot of sense. So I had one follow-up question, which is when we think about this developer experience and we think about sort of the steps to get there, what do you see as some of the intermediate ways in which we can help bring ZK snarks to the masses, to the early adopters, to the people that are willing to have a maybe slightly less beautiful experience but want to ship product faster? What do you think might an early implementation look like in terms of what might be possible in the near or medium term?
Sure, absolutely. So I think in order to get people excited about this, we have to really start talking about the use cases. We must talk about stuff that you can only build with ZK technology that cannot be built otherwise. If you show people that, then I think people are quite creative. They can come up with the use cases themselves. And if one of those use cases has a massive money-making potential, then I think we'll find a lot of enterprising entrepreneurs out there that would be willing to go through that learning curve and actually start building those applications. So I think once we show the use case and the the money-making potential for this technology, I think that's the best way to get people excited about it. That's what people got into. That's what got people into blockchains in the first place.
Right on. For those that are really intrigued and piqued by this discussion and want to learn more, are there any resources or articles or books or YouTube channels or whatever that you might recommend that people check out to try and get more up to speed on ZK and ZK snarks?
Yeah, absolutely. So I think the Electron docs is the best way to get started. I think we start with the very basic stuff and eventually go deeper. And I think you'll also find some links to some of the really, really mathematically crazy stuff. Some of those hard mathematics. I think you'll start finding links to them through our documentation.
Awesome. We'll definitely get a link to those docs posted with the video once this thing is actually wrapped. But I think that's a really incredible place here. Actually, there's one more question from Twitter that I wanted to get to before we wrap, which is a question from the Medium article. You talked about reducing transaction latency. Does that mean something like a cross-chain transfer could be sped up using your technology? If so, how would a distributed app user gain the benefit? How does this reducing transaction latency fit into the picture?
Yeah, I think I got asked this question on Twitter also. So I think we're not really reducing transaction latency here. The block production time still has to be honored, and all we are doing here is compressing a large number of transactions into a single transaction. But the latency of finalizing that single transaction will always exist. So with using ZK technology, at least off the top of my mind right now, I don't think so we can reduce the transaction latency as such.
Yep. So it's more about throughput rather than latency. Makes a lot of sense.
Yeah.
We have a few more questions rolling in here. People are getting excited. Is ZK proofs a better way for privacy than optimism rollups?
Yeah, I would absolutely agree with that, because optimistic rollups don't have the concept of privacy built in. But if you're a ZK rollup, you just have to make some small changes and the entire rollup becomes privacy enabled. Adding the aspect of programmability is a separate problem over there. But I think, yeah, generally privacy is much easier to bring to ZK rollups, more natural to bring to ZK rollups. Having said that, it can actually be brought to optimistic rollups also, in a not too difficult manner.
Yeah, I think it's interesting when you think about ZK as having privacy built in from really the base, the foundation. It's sort of intrinsic in the concept and the construction of how it works, versus trying to add some other fuzzing or other way is sort of aggregating and grouping everything such that maybe you don't know the precise how the total quantities are broken down into precise accounts or into precise UTXOs or whatever. Yeah, it's always felt to me like some of the existing privacy solutions have been somewhat tacked on after the fact and have different limitations and potential attack vectors. Like we've seen, for example, with Tornado Cache and other protocols, how there are cases where you can break them. And it's interesting to me how ZK has this much richer mathematical literature around it that offers certain guarantees around what is and isn't possible in terms of that privacy guarantee.
Yeah, absolutely. And just to build on that, basically ZK is powered by mathematics, but blockchains are powered by economics. So that's where the additional security for ZK comes from, that it's mathematically secure. So you don't have to worry about validators.
That's a great point. Question from Derek KDA, like the name. Are there security limitations with ZK rollups?
Yeah, so I think this is similar to what I was just saying, that this technology is powered by pure mathematics. So we're not introducing any new oracles or any staking networks where the economic incentives have to be aligned. So, like for example, as long as your underlying blockchain stays secure and your implementation has no bugs, then I don't think so that ZK introduces any new security flaws to the overall stack.
Right on. So I wanted to make sure that we got the docs link in the video in case someone hasn't wanted to check that out as a follow-up here. I think we are just about out of time here, so we'll start to wrap up. But we've had an amazing discussion here today. This has been fascinating. I know I've learned quite a bit about ZK snarks and some of the possibilities for tomorrow, and also more about what Garvit, you're working on at Electron Labs. Really stoked to hear that you're going to be bringing this to Kadena. I think it's going to be a huge boon to our building community. And I've no doubt that as community and other builders and folks chew on this a little bit, that we'll start to hear more discussion and ideas and engagement as to what this amazing technology might enable. So for those in the audience, I think this is an incredibly exciting time to be thinking about the space. It's new technology. It's not super straightforward to think about how it works yet, in part because outside of privacy and masking transactions, there haven't been too many killer applications that have been defined yet. But it seems like there are a lot lurking out there, that this ability to maintain more privacy might enable all sorts of other, whether it's transactions or just processing of information, to occur on blockchain. And so I think when you start combining this thread that we have in crypto of crypto no longer just being about fungible coins, but also being about NFTs, about being about permissions, about being different types of objects, that we can start thinking about how these different units of digital ownership can interact in ways that allow for new capabilities, that allow for new projects, that allow for new processes that could really allow us to build things that simply aren't possible in Web 2, that aren't possible in previous ways of doing things. And so I think anytime you have new foundational technology like that, it can sometimes be a little tricky to predict where it's going to go. But there often is that understanding, that basal understanding that this is going to be huge. I'll give a related example from some of my background in 3D printing. When I was getting started in 3D printing back in 2009, there was a lot of hype, a lot of uncertainty. People thought people were going to be printing iPhone cases in their homes, and that was going to be the killer application use case. And what it turned out to be was not really this decentralized, totally distributed manufacturing vision, but rather it became a technology that was printing wing spars in airplanes, or ducting in automobiles, or the Invisalign braces to correct teeth, or a million other applications that were more industrial. They're more behind the scenes. They impacted everyday life only because they were powering applications and use cases that people care about. And I expect that we're going to see something similar with blockchain and with ZK snarks, that it won't necessarily be that we're going to be using some cool thing because we want to use the ZK snark project company thing. It will be that, oh, wow, there's this amazing application that does something that's useful to me, and it uses ZK Snark behind the scene, and for some fraction of users that are technically inclined, they're going to think that's super cool, and maybe the early adopters will use it because of that. But for the mainstream person using something that is involving ZK Snarks, I expect that they won't even need to know the phrase, let alone what is going on behind the scenes. They just know that it serves this function and it works. So I think that it's going to be really exciting when we get there. For all those that dialed in today, thank you so much for joining us. Garvit, thank you so much for joining us here. Please find and follow Electron Labs on social media. We'll make sure there's some links in here. What's your company handle, by the way, on Twitter or preferred platforms?
It's labs_electron.
Awesome. Yeah, definitely give labs_electron a follow. Lastly, please follow our social channels on Kadena. We have a lot more discussions coming up. We're producing a lot of content around these project spotlights, doing more office hours, both for technical and for Kadena Eco. Of course, we announced our grants first cohort yesterday, so we have some exciting discussions that will come up about that. So if you want to hear more about the grants program and that first cohort and how that $100 million fund distribution is happening, stay tuned. And this is just the beginning. We're profiling a bunch of exciting projects building Kadena in the coming weeks and months. Thanks so much for tuning in, and we'll see you next time.